Hello, Augies Worldwide. I'm Dave Kassler, amateur radio call sign KE0OG, here with another episode of Ask Dave. Today we're going to look at a product that has recently been modified. Some time ago, I reviewed the Chameleon RXL, which is their receive-only loop. Like all receive-only loops, it has a small preamplifier at the base so that it can amplify the signal before it comes down the coax, because the signal that's received by these small loops is very weak. Well, Chameleon has come up with a new preamp for it, and they're quite excited about what they've done. And so I'm going to review this new preamp, which I have installed in the unit I already had, and I'm going to compare it to the old MFJ that I've had for a long time. This is the MFJ 1886. Now, there are quite a number of receive-only loops on the market, and comparing one with another is sort of like comparing verticals one with another. A properly installed modern vertical compared to some other manufacturer's properly installed modern vertical, you will find small differences between them, but fundamentally all verticals are sort of alike. Some are a little bit better than others. Now, they may be quite different in being fit for purpose. For example, if you have a vertical that needs lots of radials, you'd like to have a lot of room. If you don't have a lot of room, you might go for one of the verticals that doesn't need radials. So you see, there are differences in specifics that will tend to support one or another for your use. And we have a similar situation here where we are comparing two loops. There are some very nice advantages to the Chameleon new preamp, but overall, a loop, a receive-only broadband loop, is within a few dB, 3 dB maybe, of any other that's properly installed. Okay? Now, these two loops are both properly installed. They're up about 20 feet in the air. They are both pointing in the same direction, which is important because these receiving loops can be quite directional. So they're pointed in the same direction. Now, the day that I took the statistics that you're going to see here was during the solar flare. So I found a few signals that I was able to use as a comparison. It might have been good, because if I had ham bands that were just absolutely full of signals, it might have been difficult to say, okay, is this picture better than this picture? They were taken at a different time, and signals come and go and so on. In this case, I found signals that stayed. Okay, and I think we get a good view of what's going on here. Now, I'll, just skipping to the end and telling you this is a very fine antenna. So let's take a look at some charts that I put together to help us tell the difference between what's going on here. And I want to go through some terms and explain a few things, because just to give you a feel for what these things are looking for. Why would you want a receive-only loop? Well, some ham receivers have a receive antenna separate input. And this can be used if you like, for example, your transmitting antenna transmits great, but it's near a noise source. You can put in a receive-only antenna further away from the noise source. Another reason you might want it is for a software-defined radio. These receive-only loops cover low frequency, medium frequencies, and high frequencies. Okay, so from our 2200 band way down in the basement at about 135 kilohertz, all the way up to our 10-meter band, you can listen in to these, and because these are broadband loops, receive anything in between. So these loops are excellent for shortwave listening to international broadcasters for just exploring the various bleeps and noises that are on the HF bands, for perhaps receiving weather facts or something like that. One of these loops may be just the antenna you need. Now, they're a little bit pricey, from a few $100s on up, okay? There are some that are a little more portable than other. They are all directional, so if you really want to get into this, you'll get a rotator for the thing, or you can always go out and use the Armstrong method and turn it in a different direction. So let's jump into the charts. We're going to be looking at the Chameleon antenna's receive-only loop antenna. Their model name for this is just RXL. And what's important here is that they have a new preamp, and they wanted me to see this new preamp that we had before. Let's do just a quick review on what it is we're talking about. This is a receive-only antenna. We are talking about strictly a loop antenna that's about 3 feet across, and it has a little preamp. The reason for the preamp is because this right here picks up so little because of its size. Its capture area is quite small. So there's a little preamp down in here to get things up where they need to be. Now, I might note about these that these are actually directional in the direction of the arrows. If you were to put here an arrow coming straight out of the screen toward you or away from you, that's the direction where it's deaf. But on the sides, it can hear. Now, this little box at the bottom, which you see right here, is the housing for the preamp. Note the very sturdy aluminum plate here. You can even, it's got the standard 1/4 inch, 20 threads per inch, so you could use a standard camera tripod to hold this thing up. Or you can use the brackets that they give you to hold this thing onto a mast, which is what I did. Now, the question that you might ask is, okay, there's a preamp in there. How do we get power to that? We use something called a bias T. This is how it works. You have the preamp up here, okay, and the radio signals coming down through a capacitor to the radio. Okay, now 13.8 volts DC goes in through a coil. Now, the coil means the RF can't go through the coil. That's big enough for that. And of course, the DC can't go through the capacitor. So you put this in here and you bring it out at the other end. This bias T is built into the preamp. And you put it here, and then you've got 12 volts DC to run the preamp. And then here is the loop antenna. That is right there. This is the actual bias T that's connected to the Chameleon antenna. For some reason, they've got the radio side of this is a SO239, but the antenna side of this that actually goes out to the antenna is a BNC connector. And I'm not quite sure why they did this. My station is entirely PL259 and SO239, so I had to scramble to find some adapters here to put that thing together. They provide this bias T. They also provide a little wall wart power supply that you can put in there. Okay, so let's take a look at receive-only small loop antennas. These are wide band antennas. They cover low frequencies, medium frequencies, and high frequencies, but not up into VHF or UHF, okay? The signal amplitude is very small, so you need a preamp to feed a normal radio or your favorite SDR radio. Now, there are a bunch of these receive-only small loop antennas on the market. MFJ has one, W6LVP has one. There are a few others out there too, all in the same sort of price range. You have to look at them. The thing about shipping these is, for some, like the Chameleon, they have a solid loop. This loop around here is a solid piece of metal. It's painted gray. so it will tend to disappear a little bit into the background. The MFJ has a larger tube. It's aluminum, but it's white and very easy to see. So now, I previously did a review of the Chameleon with the old preamp, and it was a fine antenna. You see Ask Dave number 560 in the 29th of October, 2021. Now, the MFJ Enterprises 1886 that I'm going to be using as a comparison antenna is in Ask Dave 67, so I've had it a number of years. Now, both of these antennas were provided to me free for review, so I just want to make that clear. All of the antennas that we're talking about here use a bias T to put 12 volts on the coax, and I've just talked about the bias T. Now, I might note that the W6 LVP antenna is one that is collapsible. It uses flexible coax for the loop and fits in a standard courier bag. Okay, now these loops are directional, as I said, with the null on the axis perpendicular to the plane of the loop. So why the preamp? Well, the loop area is small, so the signal captured is small, but very broadband. So a preamp boosts the signal to about the level you might get with a resonant antenna, like a dipole. If done right and everything is leveled out, you can connect your resonant antenna or connect this antenna to the similar frequency, and you get levels that are comparable, not exactly the same. This particular new preamp gives a little bit more of a boost to the signal. If there is no preamp, the receiver's RF amp after the signal goes through the cable likely would not be enough to receive it. Now, it's very important to note the preamp amplifies everything, including both the signal and the noise. Okay, preamps can be subject to overloads, which can create spurious signals. For example, some preamps can be overloaded if there's a nearby AM broadcast station. And there are things that you can do with filters and so on that can notch that out so you don't have to deal with that signal. Now, what about noise? I want to talk a little bit about noise because many of you have heard of preamps in the sense of a low noise amplifier or even cryogenically cooled amplifier. This is important at UHF and microwave frequencies. Now, in HF, medium frequencies and low frequencies, three kinds of noise are important. The atmospheric noise, which you can't escape, is mostly lightning induced. Anywhere in the world at any given moment, there is a lightning strike going on. And that gets bounced around the world by the ionosphere. There's also so-called galactic noise. This is non-terrestrial in origin, meaning not weather-related. But things like the aurora actually create quite a bit of radio noise. Other things happening in the geomagnetic field as stuff from the sun comes and passes, it can create noise that will affect signals reflected by the ionosphere. Now, the third type of noise I want to mention, because this is the one that's referred to by something called noise figure. It's created by the movement of electrons in the antenna, connectors, cable, etc. And note that of these, thermal noise causes an amplifier to add noise that wasn't there before. This is why you want an amplifier with low noise figure. However, at low frequencies, medium frequencies, and most of HF, the so-called band noise, the atmosphere and galactic, are by far the dominant noise source. Now, if you're going to get up into UHF and microwave frequencies, thermal noise becomes important because the atmospheric and galactic noise kind of goes away by the time you get up to UHF and microwave frequencies. And now you are looking at noise that is created by thermal sources. Remember that your signal is being amplified many millions of times to get up to something that you can deal with, and so even the tiniest thermal noise becomes important at these higher frequencies. Now, the thermal noise, or the noise figure of a receiver, is largely determined by the first amplifier that the signal encounters. And so that first amplifier, we talk about the noise figure of the receiver. Again, it's mostly important at UHF and microwave, and that is not what we are talking about here. We are talking about low frequency, medium frequency, and most of HF. You're going to be limited by the band noise. And I'll show you some pictures of that later. Now, when you get up on 15, 12, and 10 meters, they can be very quiet bands. Now, you may have noticed this on an HF receiver. If you turn on an HF receiver or transceiver and turn on the preamps can actually introduce noise that was not there before. And in some cases, it's really nice to have that, but sometimes try this. Go up to 15, 12, and 10 meters and try turning your preamp on and off. Or some radios have multiple preamps that you can try. And see if the signal to noise ratio gets worse or better. If you have a noisy preamp, the signal to noise ratio, even though the signal is amplified, the noise is amplified slightly more. Actually, it's amplified the same amount, but the amplifier adds in a touch of noise because of the so-called noise figure. Okay? So let's just keep that in mind, that we're really not terribly interested in the noise figure of these amplifiers unless you're getting up to the higher frequencies where HF noise tends to start to fade away. Here are the two antennas. This is our test set. This one mounted on this 5-foot tripod over here is the Chameleon RXL receive-only loop. Okay, there it is, right there. And mounted up nice and high. Now this is mounted on a 20-foot mast, and so it's not quite as high as this one by a couple feet, but essentially the same. Note that they are both facing in the same direction. This is extremely important if you're going to compare antennas. They've got to be looking in the same direction. Otherwise, if this were turned 90 degrees, it'd be picking up signals that this one would not hear. This is an MFJ 1886 loop antenna. Okay, it's a receive-only loop, and nice antenna. I've had it for a number of years. It did break on me. I had it up, and a deer ran through the yard and hit the antenna, knocked it over, and broke it off from the little mount here. I was able to get a replacement box from MFJ and able to put that antenna up in a place where the deer can't get to it. Okay, let's do some actual comparisons. Now, all of the comparisons are the same way. The top is the MFJ 1886 receive-only loop with its preamp. The bottom is the Chameleon RXL receive-only loop with the new preamp. Now, I can't compare old and new preamps because the signals on the air just change too much. Here is a case on 630 meters down in the low frequency area. Well, let's see, technically, I guess it's medium frequency. But this is actually a ham band. We're looking at signals here. The top, I've got, let's just look at this one. It's the most impressive. I calculate from the noise floor here to the top of this signal a 22 dB signal-to-noise ratio. And down here, a 30 dB signal-to-noise ratio. That is a dramatic improvement in terms of the noise. So it seems to be picking this particular signal out of the noise. Similarly, it's picking these two signals out of the noise. We've got a substantial increase in the signal-to-noise ratio of that signal, and an interesting 3 dB, that's half an S unit, signal-to-noise ratio. So what I'm looking at here is the noise floor. This is that galactic and weather-related noise that is everywhere on HF. Some people say it sounds kind of grainy. And here we see that there is a larger amplification factor in the Chameleon receive-only loop with the new preamp. But what is important is not the total amplification factor, but what happens to signals. Is the signal-to-noise ratio improved or not? If it's just the same, then no big deal. In this case, for low frequencies, I'm going to give the nod to the Chameleon. There's a lot of interesting stuff to listen to down there. Now let's go to another medium frequency band that we have. This is 160 meters. Note there's more noise. I didn't, these graphs are taken with my SDR Play RSP1A, a software-defined receiver. Okay, you'll note again that there's more total noise simply because it amplifies more. And here is a case where a 12 dB signal-to-noise ratio signal drops down to 8. Again, we're within an S unit. Okay. Here's one on 80 meters where we have 15 dB here, signal to noise ratio, and we've got 20 dB here. This is the better part of an S unit, improved signal to noise ratio. It does not matter that the amount of noise increases if the signal increases at least as much or more. Okay, signal to noise ratio would stay absolutely the same if you increase or lower the gain, okay, in theory. Here's 20 meters. Now this right here is FT8, and it seems like it's much better here than here, but that's because every 15-second cycle of it, you are getting quite a bit of difference. Let's look in the middle at these. Okay, we are looking at a little bit better signal-to-noise ratio down here with the Chameleon. Same, not so much here, but here. Okay, part of this is due to the normal variability of the signals. And I took these here. There was a signal here that's not even seen here. That's because it quit by the time I took the snapshots, okay? And let's go up to 15 meters, okay? The top MFJ 1886 receive-only loop with preamp. We see we've got a little bit of an improvement down here on 15 meters. This one is also slightly improved here, but this one isn't. So what is the bottom line? The bottom line is that all the receive-only small loops with preamps will perform about the same, give or take, just like various verticals that, when properly installed, all give about the same performance, okay? The Chameleon receive-only loop is easily portable. It's very easy to take the loop off of the preamp and bias T in there. It has an impressively sturdy mounting system. Like I said, a deer got to my MFJ, although I was able to fix it. The bias T shipped with the unit performs well, and properly resisted an attempt to hook it up backwards. So I appreciate that. I had the antenna and I was trying to put 12 volt DC into a short, and it wouldn't do it. And it kept coming back every time I tried. It would drop out. And then when I hooked it up right, the thing worked just fine. One thing I like about the bias T for the Chameleon is it's got a light on it, so you can tell when it's on. My MFJ doesn't have a light on it. Maybe I'll have to put one in there. The MFJ, however, has a switch, so you can turn it off when it's not in use. Here's some comparisons between the old preamp and the new preamp. The frequency range has been slightly expanded so you can dig down into those really low signals. Okay, the power supply is the same size, the same weight, the same amount, the same. The operating voltage is the same. The gain is a little bit different. They had a gain of 25 dB at 2.5 megahertz and 12.5 dB at 30 megahertz. But now it's at least 20 dB across all the bands. Now they say that the noise figure of the old amp is 5 dB. This can actually be measured. 5 dB is a remarkably low noise figure, and they're claiming now a noise figure of 2 dB. Okay, remember that noise figure in particular measures thermal noise. So it's important when you get away from the band noise that's on the HF bands. For some of the upper bands, this would be pretty good. Noise figure of 2 dB is remarkably good and is normally achieved with a low noise amplifier or a parametric amplifier or something like that. If you have a microwave station with a 2 dB noise figure in your first amplifier, you're actually doing pretty good. So I'm looking at these noise figures that we're seeing right here with just a little bit of KE0OG's skepticism on these. Now, the figures below are for intercept points and things like that. That show that the amount of distortion created by this amplifier is less, in some cases substantially less, than what you will find with the previous preamp. Now the input, and this is extremely important, no damage. It used to be plus 20 dBm, which was 1/10 of a watt. Now the input power can be quite a bit. That doesn't mean you should go stick it in there, but don't transmit into the preamp. However, one of the very nice things about this is you want to separate your receive-only loop from your transmitting antenna by some distance, but it turns out it really doesn't matter how far away you are here. The preamp is not going to be damaged by a signal being transmitted on another antenna. Now, the input impedance, less than 10 ohms, which is good because the actual impedance of that loop is some fraction of an ohm. The output impedance going down to your radio is 50 ohms, which is good, meaning you're not losing anything by attaching a cable to it. The devices that they're using are from Infineon. They're BFP196s. There's 4 of them. Now, the protection is put in by an SMP1330 from Skyworks. There are 2 of them. Okay, well, here's something interesting. The mil-spec 2169 high-altitude electromagnetic pulse protection. This is important to preppers and people like that who just want to make sure that they're able to receive news and information in the event of a hemp event. Uses the same bias T as before. You can transmit near the loop and not overload it. This is important. A lot of people have questions about this. And of course, reverse polarity will blow the resettable fuse and the bias T, but you can just turn that around and it will reset. So there you have it. Do I recommend this loop? Well, there are a number of receive loops. I would go out there and take a look at the one that you like. Some of these software-defined receivers, like the SDR Play series of software-defined receivers, are extremely fine receivers that can tease out one signal from another, and it's nice to have a preamp like this one that is designed with those intercept points in mind to tease out weak signals without strong ones blasting over them. So in a situation like that where you're feeding a reasonably high end, I won't say that the SDR Play is hugely high end, but they really are very well built receivers, you might want to take a very careful look at this. If you're doing this just because you're a shortwave listener and you want to listen to the shortwave bands, there are a number of loops out there. You might like this one because of its sturdiness. It'd be nice to mount it on a rotator so that you can make sure that you're aiming right for the station that you want. It goes off both ends, so you can do it either way. And another nice thing that you can do with any of these loops is point the null at something that you don't want to make that go away. And that could be a nearby broadcast station or something like that. So there you have it. The Chameleon has quite a few antennas. They're working just in antennas. They are specializing in antennas for tactical work. They've been selling their antennas to the Army. They're just solid, they're sturdy, and they've got a lot of good stuff out there for you. I would like to say a special thanks to Arthur Mandolin, who is my newest patron. If you would like to become a patron, please go to patreon.com/KE0OG, and it will show you what you need to do to sign up. You can sign up at any level that you like. This allows you to be a patron for the arts, music groups, and of course, YouTubers like me. So until we next meet, 73.